Hi, this is Uli from SkyRadar. Welcome to our little webinar about algorithms that help us to detect moving objects. I'll talk about variations of moving target indication and of moving target detection. You know, we work here with FreeScopes, which is our software to track real radio signals. We get the signals here with our signal receiver. It gets live data from SkyRadar's 8 GHz pulse radar. We extract the raw data here with that module. We can work on threshold and suppress the source. Hey, talking about suppressing the source. I first use an A-scope in order to really configure the basic signals properly. And what you see here is a really bad and strong reflection of the source, which of course makes everything else small. So I first should get rid of the source. You see that source is disturbing until about 1 meter. So here in the configuration panel, I go up to 1 meter and get rid of the source. Okay, that's pretty much 1 meter. You see now all the other signals, the targets of reflectors, but also noise are getting stronger. Let me just stabilize the screen. I got the impression that the maximum pulses go up to something like 5. But anyway, it's just to set 005. It's just to set things properly. You see here soon there will be reflections. When there's reflections coming, the amplitudes go up. I should get rid of everything here that is smaller than 0.005. So let's do that here, and you'll see that the signal is going to be much cleaner already. So you see here only from time to time we've got amplitudes coming, which are then real reflections. But now we want to see whether these reflections are moving or whether it's just walls or so. So let's do the following for that. Let us look at the various algorithms that we have. And I would like to start the moving target indication, compares a frame which is coming from as a reflected signal with a previous frame. So when you compare range cell by range cell, when nothing changed, it means there's nothing moving. When suddenly in a range cell the reflection changed, we can assume that something has been moving. However, when you see here, I know that I'm only measuring the movement of a person, by the way, which is standing here. There's lots of other reflections which still come in, and I use the CFAR to enhance the screen and get rid of clutter, but it doesn't really help much. So what I do here is I add a post-processing, which is some additional analytics. Every reflection which is smaller than a certain value is eliminated. Let's also try to get the contrast a little bit bigger and see what we see here. I know that a person is standing here, so we should see a reflection in this area here. Can even make this a bit bigger. So let's see whether we get something. So we still have a reflection here, which appears to be a bit of the wall. And let's see whether it's able to see the reflection of the person. Yeah, here it is. So you see, we got rid of everything else. And just be aware, the moving target indication can work with a very simple version of a radar. It doesn't really require a radar to be able to track the Doppler frequency. So here, we get a pretty good result with a pretty simple algorithm, yeah? What you see here in the next set is the moving target detection. this algorithm, let me move that a little bit over. The moving target detection is enhanced. The advantage in comparison to the MTI is that it also tracks an object when that object stands still for a moment. Imagine a person walking through a perimeter surveillance system operated by radar, and that person stops walking. In the MTI, it would disappear. Here, it's still there. Yeah. So, what does the MTD do? The MTD, in a simple version, could work like an MTI with post-process, but in addition, it would have a second branch, which compares the original version of a clutter map with a clutter map at that very moment in time. So this is where we are, and you see it gives also a pretty good result here, but you see here also we still have that tiny reflection of the wall, which is still there. So we could certainly enhance that by giving some additional filter. So it's already a pretty good result. If we go one step further and build the MTD with the help of the Doppler frequency, yeah? So one branch takes the Doppler frequency and sees, looks out, is there anything moving? Is there a Doppler frequency in a certain range cell that indicates that there is an object? Yeah. And of course, we would have a parallel branch which looks at the change in clutter map to see whether a person or an object is standing still for a second. So this is working, and that little dot which you see here, it's not taken here anymore. So this algorithm is better performing than this one, but I'm sure that we could also get to that result here. Okay. We have 4 algorithms. They're all thought to follow the same objective. All of them have their advantages. These ones are simpler and can be done with simple radars. This one requires a more complicated radar, one that can track the Doppler frequency. This one here is perhaps the compromise, a modern approach of taking algorithms, and it can work with simple radars. So I hope you liked the presentation. If you want to read more details about MTI and MTD, go to our blog section at SkyRadar.com. And if you want to work with these training radars and do your experiments with it, just get some radars at SkyRadar.com. Talk to us, and you'll see your academy, your university, your training center will definitely benefit from a solution like that. Thank you for your time. Goodbye.